Guys, hello. This is the second video of the press arm design and simulation in Solidworks 2018. This is Wasim Khan and welcome to my channel Design and Simulation in Mechanical Engineering. Guys, in the previous video I have shown you how I design the press arm assembly and take into consideration various design factors that affect the stiffness and geometry of this press arm assembly. Now I have already covered the first part of this checklist, and now we will come to the second part, that is the topology of critical part. I have already shown you in the previous video that the middle plate is the critical part, and we have to remove some material from this part to make it more cost effective and weightless. So it is basically the optimization process which we will be doing in this video. So guys, let's start with the same model we have done before in the first part. We will take that design again and do a topology study of this press assembly. So let's start with the Solidworks. So guys, we are in Solidworks now, and this is the assembly of the press arm that we have previously simulated in our video tutorial in part 1, design and simulation of press arm in Solidworks 2018. Now the first part, design and simulation of this part in Solidworks has been taken into account, and now in this video we have to taken the typology study of this assembly. Now before we go to the typology study of this assembly, I will tell you that the topology study does not require the whole assembly. It only requires the critical parts to be taken into account. Now, as this is the assembly, so we have to separate these three parts, and we have to select those parts as our critical part to insert in the typology study that is carrying the most load, or that is carrying that you think that is the most critical part of your design. So in this example, my critical part is the bottom plate, which is carrying the load on the back side of this plate, as I have shown you in the static analysis of this study. There it is the pressure load applying on this face, and it is being transferred to all parts of the assembly. So I have to separate first this part from these two flanges, and separately insert that part into the topology study, because this part is carrying the most weight. So if you want to optimize this part and reduce the weight of this body, we have to perform a topology study and optimize that part, so it becomes less costly and more effective in stiffness. And the reason why we do optimization of this part is that we have to minimize the material cost and make it more effective and valuable than the original part. So we come to the separate part of this model. So this is the plate which we want to optimize for the manufacturing. Now I have separated this part, and it is actually the same part assembly from the model. So I want to check the mass of this part, and it is about 13.4 kilograms, so it's quite heavy. So we want to reduce the mass and uh, the manufacturing cost of this material or this plate without affecting the effectiveness and other parameters of this part. So now in the topology study, as we can see that all the features in this uh, study are the same as the static analysis without some parameters. So the extra parameter there are the goals and constraints as well as the manufacturing controls. Now these are most important in the topology study, because in the topology study there will be some goals and constraints we have to set for the model. And if we talk about the boundary conditions, the boundary conditions are the same as we have been performed in the static analysis of this part. Now as you can see, the fixed part, the fixed support are applied to the holes of this part, while the pressure is applied on the bottom section of this plate. So it is the same, it is not different from the static analysis. The difference comes in the goals and manufacturing controls. And now I define this in clear view to you, that how to set our goals and constraint, and what are our goals to optimize this part for manufacturing. Now the first goal I set was mass constraint. Now mass constraint tells us that we have to reduce the mass, and it shows us two values. One is absolute value while the other is percentage. So I select reduce mass by percentage. So there you have to select a value by how much you want to reduce the mass of this plate. So I put 50 there, and this shows us that the mass of this plate will be reduced to about 50%. Means that it will become half when the topology study of this part has been successfully done. Now in the second constraint I put a displacement, and I have put a value of 1.2. You have to put there a factor by which factor you want to limit the displacement to a certain value. So you have to put a value, and this is the default value. It is 1.2 placed by the Solidworks. So I remains it unchanged, and this is our constraint for the goals. And now we come to the manufacturing control. Now in the manufacturing control there are some parameters you have to define. The first one is the preserved regions. The preserved region shows us that you have to preserve those regions that are most important. Now those regions are most important to which boundary conditions are applied. So you must keep that faces, and so that your body cannot produce any error in the simulation process. So you have to keep that faces to which boundary conditions are applied. Now there are some other optional regions that you want to control. So that is depend on your needs and the geometry of the model or part that you want to preserve. So I applied those faces, select those faces, and because I want to preserve the geometry of this part, and not to remove all the outline of this. I want to preserve the outline of this part to be as it is. So when the simulation is done, the topology results shows us that it will only remove material from the middle portions and preserve those regions that are most important, that is the boundary condition regions. So it is according to your requirements that which regions you want to preserve and which you are not wanting to preserve is depending on your requirements and model. So this has been defined. Now we come to the thickness control. Now the thickness control is by default set to 0.425 inches, and it shows us that the minimum thickness of this plate couldn't be decreased from 0.425 inches. So I select this value as my default value. So it is also done. Now we come to the symmetry. This is the final constraint I have applied to this topology model. Now there are three types. One is the half constraint, quarter symmetry, half symmetry, quarter symmetry, and 1/8 symmetry. Now my model is quarter symmetry, so I applied quarter symmetry because it is symmetric about two planes. So I select those two planes to which about which my model is symmetric. Now the whole model has been defined, and now I have already simulated this model topology study, performed this topology study. So I only select the result and will show you how the Solidworks simulation remove material. Now as you can see, those faces that I want to preserve doesn't change so much. You can see the geometry of the part has been preserved on the outside, while SolidWorks removed those regions that are not very much important. Now it has been removing material from this region and from this region and in the middle region of four regions. And if you want to save this file and you reuse it as in your analysis, you can reuse it, but to make it fit for machining, you have to make those edges that the SolidWorks topology analysis removed to make these regions smooth. Because SolidWorks remove elements from those regions that are not so much important for the analysis, or from those regions where stress may not be so critical. So as far as this design is concerned, I have redesigned the part into a new SolidWorks file, and I have applied the same procedure as the SolidWorks topology simulation has been done. So let me show you how I designed that part into a new SolidWorks file. Now I removed the regions from those parts that the SolidWorks simulation, topology simulation have done before. And in the middle, I removed some regions from there. Now, if you want to check the mass of this part, as I have shown you earlier, the mass of this original one was about 13.4 kg. And now if I want to check the mass of the modified plate, it comes out to be 8 kg, approximately 8 kg. Now there is a difference of 5.5 kg. So guys, that's it for this video, and we have successfully performed the topology analysis of the critical plate, and we have been modified that part into a smoother part design, so that it can be easily machined. And you also see the mass of the body uh, as it was previously, and it is now in the modified model. So it is a difference of about 5.5 kg for the new design, and it is very flexible and a very good tool for removing material from the parts, and you can use it in every design to make your part more compact and flexible. Now guys, in the next section we can see the force and pressure load applied on the modified plate that we have been simulated in the topology simulation tool. And we have to compare both the load types. We have to apply a force and a pressure load on uh, two different analysis types, and see how it behaves. And also in the next video you can see the fatigue analysis of those of this press arm assembly. So hope guys you could understand this topology analysis of the press arm plate. uh, if you like my video, please comment in the comment section, and also like and subscribe my video, and click the bell icon to see more notification of my videos. For now, thank you very much.